Hi, this is Dr. Liu. In this video, I'll show you how to read a pulse sensor with the adapter. So here I have a flow meter, and the flow meter has a rotor that's inside. You can just gonna blow into it to cause that rotor to spin. And the spinning rotor has a small magnet that carries with the spinning rotor. And this sensor has a Hall sensor. Basically, the Hall probe is sensing the spinning of the magnet around it. And this is a 3-pin connection. The Hall sensor needs power, so the plus is the power, the 5 volt, the minus ground, and the center pin is the signal, that is the pulse. So I have the adapter. I also have my phone here connected. So let's see. Let's just start from beginning. I'll disconnect, and okay, I'll connect again. And this is the terminal program that I showed you in other videos. This is the serial terminal program you can get from Android Play Store. It's a free program. So I program these buttons to do certain things. For example, if I just long click, this says ZI exclamation sign. So this is asking for identification. So if I press, oops, all right, it's not connected. I got connect and press that. Okay, it identifies itself as the adapter, SDI adapter. So the TRD actually means translator. So now I have it, and I'll connect this. I just need to make sure the blue pin in here is the 5 volt, and then the gray pin is ground. So I think the best way to do it is to use the plus pin here near the 0, and also the minus pin near the 0. So I'll just hold this thing here, just like that. I'll just apply a little bit of pressure for connection. So the command to sense pulse is a ZM9 exclamation sign. So this senses pulses on all 4 channels at once. And the first time we run this command is going to reset the pulse count to 0. So if you do this and then do D0, and then you can see 4 zeros here. Let me see if that's recorded. Okay, yeah, I guess it is. So 4 zeros, and then this is starting point. And then if you have pulses, then it'll show up on the next ZM9 reading, and then after the reading, the pulses are reset to 0. So if you want to say, for example, you want to count how many pulses per minute, you can just send this command ZM0, and then do a ZM9, excuse me, and then do a ZD0, and that is the count since last time you read it. And then in 1 minute, you repeat that ZM9 and ZD0, so then it will give you the counts since the last readout, which was a minute ago. So if you time your reading, you'll be able to calculate pulses per minute, for example, like that. So let's give it a try. Now we have cleared the pulses. I can just blow into this this water. This is a flow meter. That's going to be hundreds of pulses, and may still be spinning quietly. So I'll do a ZM9, ZD0, okay, 656 pulses. And is it still spinning? ZM9, ZD0, no more spinning. I guess by the time I press ZM9, that rotor has stopped. So I can certainly blow harder and keep reading just to see the effect of the counts. Okay, so I got about 50 counts after that reading. So assuming water keeps flowing, then you keep getting counts. And one thing about the counts is the counts are actually transitions. So you could have a pulse that goes from low to high, and that gets counted. And then another pulse that goes from high to low, that also gets counted. Because different sensors work differently. Some actually require the low to high, others high to low. And even other sensors can count at both low to high and high to low in order to double up the amount of count they can provide. So if your sensor only activates at a certain pulse, say low to high, all you have to do is take the number divided by 2, because these numbers are almost always even numbers, unless somehow just the rotor settles at a location that you only went from low to high and never went back to high to low. That could happen because the rotor is not dedented like a rotor encoder that will always fall into a dent that finishes the whole pulse. And another thing I want to talk about is this is a digital sensor with a Hall probe, and it has hysteresis. So each pulse is a pulse. But if you have something that doesn't have a Hall sensor, for example, if you have a let's think about a read sensor. Basically, a read sensor is a sensor that can sense magnetic field, just like this Hall sensor, but it bounces a lot. So the contacts will connect, bounce back, connect, bounce back many times for one particular pulse. That, say, if you consider a pulse as something rotates one turn, or maybe a tipping bucket ring gauge tips the bucket. So you must have some sort of methods to filter out those fictitious bouncings of the contacts. I'll have a different video to kind of talk about how these fictitious pulses are coming out, and how to do a very simple filtering to filter out those contacts bouncing and only get the exact count you need. All right, thank you.